Hello everyone, welcome to one more video. Today I'll be talking to Vinay Rao. Vinay has more than 20 years of experience playing different leadership roles among various companies. But 4 years ago, he co-founded RocketML, a company dedicated to make the difference with machine learning and AI. You understand his mindset, his perspective on how machine learning can change the world, how to adjust ourselves to think as a data scientist, as well the skills needed for it. So if you like it, please smash the like button. And again, don't forget to subscribe and activate the notification bell so you don't miss anything in the future. Let's go!
I'm a founder, one of the founder of RocketML. We make a machine learning platform to help data scientists and researchers to go from raw data to a model that is efficient and optimal. And in order to deliver that promise, there are a lot of problems, both intrinsic machine learning problems, as well as organizational challenges like security and cultural teamwork, all the other challenges come. And the product that we have, we kind of work to solve those problems and make it useful for enterprises.
What do you think is the real role of a machine learning structure within an organization?
Yeah, so there is a quick answer to that. The real role of machine learning is to eliminate subjectivity and base most of the activity based on the data, facts. That's the noble goal, and I think we are heading in that direction. I joke about this. Machine learning has been around for decades, and but it's still a baby, and for that reason, it must be Baby Yoda. You know, we don't see the physics of it, but it is like that. It is like a Baby Yoda. It's still a baby, and in a tangible way, eliminating subjectivity delivers significant value because some software engineer, when you put a software out there, software will have to make some decision based on rules, and some software engineer or a business analyst, whoever decided to put the rules in a software, that's how the software is working. Some of them are deterministic in way that you know the rule and you put it in. There is no reason to additionally waste your time spinning wheel on that. That's fine. But what you find is that in a software, a traditional software, a lot of the rules are written based on the biases of the humans, of a software engineer, and it's not even a consensus bias. It's not even decided by the top management, people who know the best. It's written by somebody at some point in time, and it's never modified over a period of time because it's too hard to go back and fix the code. So that is the very inefficient way of creating software. A data-driven software is one where you generate these rules we call models based on purely data, and you replace you embed that model into the software that works with humans, and that becomes a new type of software. I don't know if you heard of Jeff Dean. He's the head of Google Brain, and he gave a quote in one of the presentation that Google Translate, which is one application software that they have that translates English to any language, vice versa. They had a code base of 500,000 lines or so, and they were able to reduce the code base to just 500 lines by replacing all these convoluted rules that they had written coded into the software and replaced it with machine learning models. And the code base came down from 500,000 lines to 500. And that is enormous transformation. If you are a software engineer, one of the things you will you hear from most software engineers, they hate working on somebody else's code. If you haven't written it, it's a pain to work on somebody else's, but they're forced to work on it, right? Now, instead of going through this 500,000 lines of code, you are dealing with 500 lines of code, and you're dealing with a specific model that you can test it offline and validate it. Sure, you won't have 100% certainty about it until you put it into the real world, but at least you can build a system around that to measure objectively how this model is working, and when to kill that model, when to replace the model. All those things are becoming new business of software, so to speak.
Software developers, they will need to continue developing themselves.
That is correct, because to build a machine learning application, it's a whole new skill set. Your software skill set is useful in some ways, but it is an entirely new set of skill sets. It's now called data science. It's a science skill set. You see that a physicist, a well-tried physics PhD, is very easily able to jump in and become a data scientist because they're trained as a scientist, versus a software engineer finds it much harder. It's not impossible. They find it a little harder to change their mind to think like a data scientist. So it's a different mindset.
For sure, to create new models, right? So you have this system to predict how to operate. This is an amazing thing to do. This can generate a lot of good things, right? Optimize their supply chain. They can increase their sales, and at some point decrease costs. Do you agree with that, Vinay?
Correct. Absolutely agree with you. This is what I was describing before. Software, new type of software, is a transformational benefit. But in addition to that, machine learning can also predict. When it comes to prediction, there's always a risk involved. But a data-driven prediction is any day better than somebody trying to make prediction based on their biases. When you can predict failures in a predictive maintenance scenario, or predict stock required in supply chain, then you're connecting to business goals versus efficiency goals of software to now the business goals, and that's when you see 10x improvement in the return on investment. I totally agree. I think hundreds of graphs that are floating around on the internet that shows descriptive to predictive to whatever the 4 or 5 stages of the data analysis steps are. I think the promise of that is definitely can be met with machine learning. So far, I would say the success of it varies across industries, and it's entirely dependent on the data also.
We know that to gather that certain amount of data requires a lot of technology, and we didn't have this technology in the past. That's why probably conceptually machine learning was there, but now we are able to get a lot of data. But we do have the downside of that. We are gathering a lot of data, so the data scientist will become very happy, but I'm not sure if the IT security team is so happy about that. Different goals, different perspectives on how they want to use data, how can they use data. So what's your feeling about that, Vinay?
Yeah, we joke around in every customer, we joke around this, in fact, openly, that, data scientists are from Mars, and IT engineers, application engineers are from Venus. It's definitely a different mindset, and IT folks, want to keep the lights on and protect and all the defensive activity that they take care. Whereas a data scientist is trying to invent a new world altogether. So they are totally different. So that problem can be solved. This is not a unsolvable problem. And in fact, as our company product, RocketML, we focus on solving that problem. Well, that's one of the problems we try to solve. We call that a bridge problem.
Mm-hmm.
The siloed products, when you with the siloed, you can build product in multiple different ways, right? Software products, you can build a product to solve a very specific problem, or you can build a product that connects multiple siloed product to make it into something that works across multiple products.
Mm-hmm.
Or third, you can build an end-to-end product, right? We're gonna try to do the end-to-end product. And that bridge is the missing piece. And when we show what we mean by that bridge between a data scientist and a data security team, they get very comfortable.
Mm-hmm.
On our platform, for example, we track every bit of data that goes into data scientists. One of the needs of a data scientist where the cultural differences play a massive fight is that data scientist says, hey, I want access to all data,
Mm-hmm.
right? And the security guy said, well, you are an employee, but I'm not supposed to give access to all data for you.
Mm-hmm.
So what problem are you going to solve? And it is, I need to see the data in order to decide what problem to solve.
Sure.
So this continues, right? So what we tell the security guys is that, listen, give full access to data, but you can track what they did with it every single day. And we instrument it and make it easy for you to track. The data lineage is maintained, data usage is understood, and we also, on the cloud, all these things are much easier to build than in a data warehouse or data centers, etc. It's not impossible. You can build all these functionalities. What we also show them is that data HIPAA shouldn't be, HIPAA law shouldn't be just for healthcare companies. It should be for everybody, like not as a regulation, but as a mindset goal to achieve.
Mm-hmm.
And you can achieve that, right? You can encrypt the data these days. Technology is there across, at rest, during transmission. You can secure the data. You can encapsulate in such a way that there is no outside information coming through. You can firewall it. So there are so many known technology that we can use to build that highly secure system that it shouldn't be a concern at all,
Mm-hmm.
right? And the moment you do that, data scientists are happy, right? They will not. On the other hand, the second problem that comes to mind is the data scientists, the technology underneath the data scientist is changing very, very rapidly, right? It's not like the IT or productivity softwares, they move very slowly. Operating system move very, very slowly, right? They don't change very quickly. But the data science technology changes very rapidly. Next week, Google might release a new open source software
Mm-hmm.
that increases the efficiency by 10x or whatever for free, right? It would be silly for data scientists to be locked into some old technology. The technology become obsolete within weeks, not decades in data science. So we have to create an environment for them where they're able to test out new things that come out in the market without any security risks, without IT, depending on the IT support.
Mm-hmm.
So when you take care of these things, all these cultural problems start to disappear. End of the day, you hear it all the time that the culture is stopping me. That's only a symptom. But the real root cause is that the systems and the tools are not sufficient. And in addition to that, the talent and the mindsets are also, you need to work on that too. Like a data scientist, when they get data in their hand, not everybody succeeds. It's still not easy for them to build a great model. It's still a lot of work. And these challenges have to be solved technology-wise. And at the same time, you have to train the people to solve the real problems.
We both agree that at the end, there is like a restriction posed by the IT security team. They like is at least make the progress for the machine learning team. They make the progress a little bit slower. Do you feel that? At the end, we know that the senior leadership plays a very significant role on that, right? They are ultimately responsible for the level of risks they want to accept from a data security perspective. But at the end, they are the team who is setting their goals. Do you agree?
But I think from purely based on their objectives, difference in their objective, it is a source of friction for sure. Mm-hmm. But I think things are also changing rapidly. Any public listed company that I am not aware of, if we speak to hundreds of them, the ones that trade on NASDAQ or Toronto Stock Exchange, those companies, almost all those companies, boards have given CEOs specific targets to achieve on artificial intelligence journey transformation. And when it is that top down, security teams, CISOs have to hustle and catch up to that reality. And now it's upon them to participate as part of the solution versus staying behind the scenes and making sure everything is protected. Just playing the defense game is not going to be sufficient for them. The good news part is that a large portion of the machine learning work is offline. What I mean by that offline is that when the data comes, sure, you can do the machine learning. There is a lot of work going on machine learning on the real streaming data and stuff like that, but it's still a very research phase. There are tools for sure, but most data scientists want to take a batch of that data because you need sufficient data to do a good buildable model. What they do is they take that batch offline and learn on that. You let the machine, you run a bunch of algorithms to learn on that data and see if a optimal model comes through, and then they test on the real data coming through, and there you go. So there is no security risk on the offline work that they do, right? So the moment the CISO organizations realize that, okay, this is an offline work, they're not talking about putting a model in production. That's when the temperatures go up again, the friction from the temperature from friction. So it's just offline work, they become a little more comfortable. It's a communication challenge. And the top-down pressure helps speed up that communication problem. Companies like us, will go in with new language, so to speak. We speak a different language than what's going on inside the company. We are able to explain in a different way. You have to be able to explain these types of topics to a 5-year-old, right? And when you do that, it's not that they're 5-year-olds. They're very, very capable, technically savvy people, but the friction makes it hard for them to hear the other side. So you kind of explain in a simple way, then things move. And we generally don't, in our own working with our customers, we don't see CISO organizations as a major barrier. We sure have to go to them to get their approval, but it definitely not a major pushback.
Because they understand why you were there, right?
Correct.
The benefits you can bring to the table.
That's right. That's right.
And with all this pandemic situation, we are seeing, I've been seeing actually a lot of acceleration when talking about put some new strategic plans to become even more efficient within the organizations. And we know that machine learning plays a amazing role when you're talking about efficiency. Uh, if you're talking about a short-term period, Vinay, a medium-term period, what do you think machine learning will become to the organizations?
In the medium term, I think all the softwares are going to try to replace applications, will try to replace the manual rules that they've written within, baked into the software, replaced by models, particularly where it's not deterministic, it's probabilistic, and also where it is becoming humanly impossible to write these rules. There's only so many ways a human can think of how a fraud can happen in a, let's say, insurance claim. With experience you have, but when you do the machine learning, you're able to find different patterns of the fraud. That you, instead of identifying 4 fraud types, if the machine can increase that to 10, that's a great win. So we see, whether it is in insurance industry or in financial services industry, the number of machine learning model getting baked into application exponentially growing, replacing rules-based software with machine learning model. That is happening as we speak, and that will continue into the medium scale. The longer term, I think the companies will focus a lot on what is the data that will actually give me signals. They'll focus a lot more on collection of the right kind of data and use machine learning to get that data. It's not collect everything, current system, collect everything and find pattern. Instead, collect things that might matter and keep adjusting that also, and use that to instrument the entire business. Today, there is dashboard instrumentation going on, but this instrumentation I'm talking about is more like a cybersecurity system where you're collecting a lot more data on this, network architecture. You can collect at different layers, different kinds of data, log data that comes through, and then you instrument it, and then you build model on it, and then let the machines protect your systems, right? And that is happening on the cybersecurity side, and that level of performance will go to the business side of the equation also. You can see that progression coming, and that's on the commercial side I'm talking about. Mm-hmm. But the implications on the healthcare, implication in the scientific segments is also just enormous implications in those areas. We work with a number of biomedical companies where the ground truth itself is not known. So, for example, biomarker is a indicator of something that's going on in the body, a human body. But not all biomarkers are known, right? With the known type of a device, people collect terabytes of data. Like when you take a blood sample and put it into, convert that blood sample into data, right? Numbers, actually, it's a matrix. And in that matrix is so large, and there is so much unknown in that matrix of data that most researchers, what they do is they throw away 90% of the data because they don't know what to do with it. They throw away, using their medical knowledge, known medical knowledge, they throw away the data and they analyze on the rest of the data, remaining small amount of data. I would imagine machine learning will start to make sense out of the thrown away data and start to improve the ground truth instead of us knowing only about 100 biomarkers, you begin to know thousands and thousands of biomarkers and be able to precisely say, hey, here is the combination of biomarker that lead to this type of a phenotype definition. And in that phenotype definition, this kind of drug works better, and be able to precisely say that. Precision medicine today is just a term, but it's not necessarily that precise. So we will get there in that area. Also in the oil and gas, energy sector, scientific sectors like material design, everything you can apply deep learning techniques to improve the process of discovery significantly.
For those who is still not in this area, Vinay, what would be your recommendation to someone that wants to start working as either a data scientist or a data analyst?
I have a very high level, 50,000 level suggestion, which is develop the mind of a researcher, develop the mind of a scientist, because scientists are not absolute, right? You look to generate a law, like Newton's law, whatever it is, but you're also open to finding something that is a anomaly to that law. So that scientific inquiry is required in all sectors of society. Once you develop that curiosity and scientific way of thinking, then it becomes much easier to learn the Python language or whatever that it is. I wouldn't necessarily say it's easier to learn. I would say you can still, you have programmatic thinking is another challenge for sure. But combining that programmatic thinking of a programming language to what is needed in a data science, which is scientific thinking, becomes easier. Right now, a lot of the data scientists struggle, even though they take all these courses, they keep spending a lot of time to train themselves up. But they still, until they learn how to think scientifically, they struggle. They struggle to do their jobs. They struggle to communicate to their management why they're doing what they're doing. And a typical data scientist faces a lot of criticism from their management and also people who are not data scientists. These are the two criticisms they hear. One is that he's on a fishing expedition is a common thing you hear. People who are not data scientists complain about a data scientist. And that's because of the communication, that they haven't had a good communication at all. The data scientist probably hasn't done a good job of explaining what they're trying to do. And the second thing, the non-data scientist, business guy or a application engineer would say is that he doesn't understand the business. So there's a simple root cause there, but again, the moment the data scientists are able to explain why they do what they do, things improve dramatically, and they need to kind of develop that skill as much as learning how to think programmatically.
I couldn't agree more, Vinay. And this is almost the same answer that I give when someone poses me this question, right? Because we see that we have these new young people want to learn, okay, I want to learn Python, I want to learn R, I want to learn so many code languages, platforms, tools, and etc. And they are putting all their efforts on the technical piece, on their hard skills. But you also need to understand your business. Otherwise, you cannot add value to your business.